Hi, in this problem we're going to prove that n squared minus 1 is divisible by 8 for all odd integers n. Proof. Before we start the proof, let me briefly recall what it means for a number to be divisible by another number. So we say that a divides b, or that b is divisible by a. This is equivalent to saying that b is a multiple of a. So b is equal to, say, some integer m times a, where m is an element of the set of integers. So a divides b, or b is divisible by a, means that b is a multiple of a. So here n squared minus 1 is divisible by 8, means that n squared minus 1 is a multiple of 8. Let's go ahead and go through the proof. So we'll do the base case first. In the base case, we have to show that our statement is true for the smallest odd integer. By the way, this should say all positive odd integers. So the smallest positive odd integer is 1. So when n equals 1, what happens? Well, this will be 1 squared minus 1, which is 0, which is equal to a number, 0, times 8. So it's a multiple of 8. So the statement is true when n equals 1. So our statement is true for n equals 1. The next step is called the induction hypothesis. So induction hypothesis. In this statement, we assume that our statement is true for some positive odd integer k. So suppose k squared, so basically you plug in a k for your n, k squared minus 1 is divisible by 8 for some odd positive integer k. Say it's k equals 2p plus 1, where p is an integer. Right, and we can say it's written this way because that's what it means for an integer to be odd. So if an integer is odd, that means we can write it as 2p plus 1. So this is really important to use and know in this problem. So because it's odd, we can write it that way. In the induction step, we have to show that our statement is true for the next odd integer. So the next odd integer is going to be the following. So claim our statement holds for k equals 2p plus 3. That's going to be the next odd integer, okay? Very, very key because we're only dealing with odd ones. So now we basically have to plug this into our original statement and show it's a multiple of 8. So recall our original statement was n squared minus 1. So now we have to show that it's true for this here. So 2p plus 3 squared minus 1 to show this is a multiple of 8. So then, this is equal to, so you can multiply this out. There's a formula. You square the first one, 4p squared. Multiply these and double them. So 6p times 2 is 12p. Plus you square the last one, 9. It's just a formula to multiply it out. So square the first one, you get that. Multiply these and double them, you get that. Square the last one, you get that. Minus 1. And this is equal to 4p squared plus 12p plus 8. Now let's think about what we're trying to show. We know that k squared minus 1 is divisible by 8. Okay, that's our induction hypothesis, right? That's what we have. So what does that actually mean? So let's just come back up here and just think about that. So that would mean that, let me use a different color. That would mean that 2p plus 1 squared minus 1 is a multiple of 8. So that would mean that, well, this would be 4p squared plus 4p plus 1 minus 1. Right? Multiplying this out gives you this. Okay, so that's basically saying 4p squared plus 4p is a multiple of 8. So down here, what we're going to do is we're just going to work with that. So we have 4p squared. We're going to borrow a 4p from the 12p. Okay, and then I'm going to write it like this, 8p plus 8. Let me just go over that again. So we're working this out. We've written down our hypothesis. We go to the induction step. We plug in the 2p plus 3. We get here, we say, okay, what's going on, right? What is going on? So how do we do this? So we have to use the induction hypothesis. So you go up here and the induction hypothesis says that k squared minus 1 is divisible by 8 for some odd positive integer k. Well, k is 2p plus 1. So what does that mean? That means if you plug it in here, it's going to be a multiple of 8. So this is a multiple of 8. So this is equal to 8, let me use m. And then here we still have plus 8p plus 8. And this step here is by the induction hypothesis. That's the key step, okay? And this is for m and z. So m is an integer. Okay, so this is equal to this because that's what it means for this to be a multiple of 8, which it is a multiple of 8. It's divisible by 8, right? We assumed it. So then we can factor out an 8. So this is 8 m plus p plus 1, where we know something about this. M plus p plus 1 is an integer. So we've shown that this is a multiple of 8. So 2p plus 3 squared minus 1 is divisible by 8. So we showed that the base case is true, and we showed that if it's true for some odd positive integer, it's also true for the next odd positive integer. So therefore, by the principle of mathematical induction, our statement is true. So thus, by the principle of mathematical induction, we have our statement, which was n squared minus 1 is divisible by 8 for all odd positive integers n, and that completes the proof. So, yep, that's it. I hope this has been helpful to someone out there. Good luck.